Yeah, cool. Thanks so much for having me. The title of my talk is Beyond the Here and Now, Counterfactual Simulation and Causal Cognition. And thanks so much again for the organizers for putting this together. Unfortunately, I wasn't able to be here on the first 2 days because I had to teach on Tuesday. So I only caught what happened yesterday and today, but it's been terrific what I've seen. So one of the things that I'm interested in is counterfactual thinking, right? So the way that we as humans can go beyond the here and now and think about other things that could have happened instead. And in this talk, I want to structure it into two sections. So on the one hand, I'm going to be interested in how counterfactual thinking comes to play when we explain things, when we say why something happened. And then kind of hot off the press, at least for me, or not even in press yet, actually, I've started to think more about how counterfactual thinking also affects the kind of decisions that we make in our everyday lives. And if you look at the abstract, like all that is just about this first part, but I was a little bit like the selfish agent, I guess, in Max's simulations, and that I was excited about this work that we've done quite recently and wanted to share that with you too. So that's going to be part 2. And I have never talked about that part 2 before, so hopefully it'll go smoothly. But let's start with the first part on explanations. So I think there's 3 key ingredients that we need in order to get some computational model of how people explain why something happened. And the kinds of things that I'm going to be interested in is explanations of particular events, like, for example, this caused this thing to happen, rather than general causal statements like smoking causes cancer or something like that. So what we need, I think, is some mental model of the world, a particular kind of mental model, namely one that supports thinking about counterfactual interventions on that mental model, and then the ability to simulate what the consequences of those counterfactual interventions would have been. So I think Daniel yesterday in his talk also was talking about Carl Craig, right, and this idea of us carrying this kind of small-scale model in the world. And you've probably heard quite a bit about the physics engine in the mind, I would think, on day 1 or 2, maybe in Kelsey's talk or in Ilka Yildirim's talk. So this idea that at least when it comes to our model of the physical world, that it might in certain respects be similar to the kind of physics engines that we have in our computer games has been popular in cognitive science, right? So that idea being that we take in the world through our perceptual senses, that we then build some internal representation of that world, for example, representing the objects and their properties, and that this internal representation then allows us to simulate possible things in that world. So the kinds of things we could simulate, for example, is make predictions about what's going to happen in the future. So I can go from the current state, right, plan some action, and what's going to happen to that tower when I roll the block when I roll this ball against it. I can also make inferences about what happened from seeing the final state, right, sort of Sherlock or detective style, to make inferences about the past causal story that must have led to this situation that I'm finding myself in. And I can also use this internal representation to explain why it is that something happened. So if I want to say, for example, okay, was it because of the ball in this instance here that this tower fell, right, I might envision some counterfactual simulation in which I hadn't taken that action and compare that to what actually happened, and might conclude in this case, yes, it was because of the ball in this instance that this tower fell. So I've been interested in this, how we build these internal models of the world and how we use them then in various kinds of ways. And I have to warn you, I'm a psychologist, right, and you're going to be participants in quite a few times, actually, in this talk, so don't doze off too much. The first question I'm going to be interested in is in how people use their mental model of the world to make causal judgments. And here's the first experiment, right? So I'm going to have these 2 billiard balls come in to the scene from the right side, and I'm going to ask you whether you think that ball A caused ball B to go through the gate. Okay, so who thinks yes, it did? You raise your hand if you do. Okay, I did prime you a little bit, where I told you about counterfactuals and things like that. Obviously, I don't do that in my experiments. Don't tell them anything about counterfactuals. But nonetheless, I think counterfactuals is what comes to people's minds very naturally. Right? So this idea that we propose is that when people make causal judgments like that, they look at what actually happened. That's certainly non-controversial, right? That the balls collided and then B went through the gate. But that people go beyond that they also naturally envisage what would have happened in the relevant counterfactual situation here, right? And that we have the capacity to do so, that we can, in our mind, imagine what would have happened if ball A had been removed, and then simulate, using our intuitive little physics engine in our mind, where this ball would have ended up in this case. Right? And then it's really sort of, in some sense here, an epistemic notion of what it means to be caused, right? It's your subjective degree of belief that the counterfactual outcome would have been different from what actually happened that determines the extent to which you say, yes, I think it caused it to go in this case, right? The more sure you are. So this sort of model, right, builds on ideas, many of which have actually been developed here at UCLA by Judea Pearl and others, right? So this idea that we can have a representation, a causal representation of the world. In case of Judea Pearl, that would be a causal Bayes net or some structural equation. Then we can define formally what it means to compute counterfactuals over that by, for example, having a tool such as the do operator in that language. And we take that as inspiration, but kind of basically replace the generative model of the world with something different in this case, right? It's not a structural equation or a causal Bayes net. In this case, it's a physics engine that we assume is in people's minds. And then we also postulate different sort of counterfactual operators that people might have on top of that physics engine. In this instance, for example, the capacity to imagine the removal of some object and then replaying the world without that object. So you might say that's the only game in town. Like, what else could you possibly be doing? Right? And there's another proposal, though, quite prominent in psychology and also in philosophy, that basically does away with this part, right? That says you don't need that counterfactual stuff. All you need in order to make causal judgments is there in the actual world, right? These are called actualist accounts of causation. And one model that has been developed by Philip Wolff, the psychologist, called the force dynamics model, is an implementation of that kind of idea. So it says all you need to know is what forces were present at the time of the causal interaction, and that's what's grounding the meaning, for example, of these different causal expressions here in this case, the difference between cause, enable, prevent, and despite. And just applied to that billiard ball setting, right? We have a patient that has some force, that's ball B here. Then there's an agent that imparted a force on the patient, like indicated by this vector A here. We have a resulting vector, and then an end state, whether or not, in this case, the ball B went through the gate. And the idea is if we have that configuration of forces, yes, then the word caused is true. Right? But it doesn't require, according to this model, simulating, for example, what would have happened to ball B if ball A hadn't been present in the scene. And so I want to show you in the next few slides that I think actualist accounts don't work, right? That you need this assumption of counterfactual simulation if you really want to explain how people make causal judgments about particular events. One thing that's nice about the kind of framework that we've been developing, and this model here also cannot do, is to derive quantitative predictions about the kind of judgments that people should reach. And those quantitative predictions from our model arise from the fact that we think that people have some uncertainty about what would have happened in the relevant counterfactual situation. Right? So that shows you sort of the ground truth here on the right-hand side, but you don't know that. Right? You have to use your imagination, right, to play out how this counterfactual would have gone. And if we assume that you have some uncertainty in that, the way that we can implement that in a physics engine is by adding a little bit of noise in the simulation and then drawing a sample, a noisy sample from the physics engine, then maybe your counterfactual simulation would have looked like something like this in this case, right? And you could draw another one and another one. But in this instance here, you'll be relatively certain, right, that A caused B to go through, because in all of your counterfactual simulations, 3 in this case that you drew here, it would have missed, right? So you're pretty certain that it went through. But in a situation, or that it caused it, sorry. But in a situation like this here, right, where again A collides with B and B goes through, but this time here the counterfactual is much less clear, right? It was sort of headed right towards the goalpost, basically. And now when you run your noisy simulations about what would have happened, well, maybe ball B would have missed, but it's also possible that ball B would have gone in anyhow, even without ball A being present in the scene. And so accordingly, you should be less certain, right, that A caused ball B to go through the gate in this case here. It's at least what our model predicts. So in our experiment, we show participants a bunch of clips like that. And then between conditions, we asked them a different question about those video clips. So one group, we asked a counterfactual question. So we asked them, would B have missed the gate, if ball A hadn't been present in the scene? And then here, they're pretty sure that it would have missed. Here, they're kind of uncertain right at the middle of the scale. And here, they're pretty sure that ball B would have gone in anyhow, even if ball A hadn't been present in the scene. And then if you ask a separate group of participants who make a causal judgment, so those participants who didn't tell anything about counterfactuals, we see, though, that their causal judgments align very closely with the counterfactual judgments of the other group of participants. And we can also use that kind of noisy simulation model, right, that I pointed out earlier, and it would also yield similar judgments in these kinds of cases here. These were just 3 of the clips. In total, we had 18 different video clips in that experiment. And what the scatter plot shows is just the average counterfactual rating on the x-axis, and then the average causal rating on the y-axis. And you see that they align very closely with each other, so suggesting that, yeah, maybe this process of counterfactual simulation captures the way in which people are making causal judgments in this domain. When we published this work, though, this was a COGSAC conference proceedings paper, one of the reviewers was not particularly pleased because they said, well, all these video clips that you showed us, something different was going on in them. So it's still imaginable in principle that you could develop an actualist account that would capture the judgments that people made. We tried to develop an account like that and failed, but also we kind of wanted to fail, so it was not the most maybe convincing argument. So what we did instead then is came up with a different set of studies. So we felt like if they come up in the way that we think they will, there's not going to be any way that an actualist account could explain those findings. So do we really need counterfactuals if you're not convinced basically by the quantitative mapping? So here's another round of audience participation. This time I'm going to ask you whether you think that ball A prevented ball B from going through the gate. Okay, show of hand. Do you think it prevented it? If yes, you can raise your hand. A few hands go up. Okay, some hands don't. Okay, let me show you another clip in the same world. So it wasn't a glitch, right? So I just implemented this little teleport in here that only works for ball B. It doesn't work for ball A, right? And so if it goes, ball B goes into this yellow object, it comes out of the blue object in the same way that it entered, right? A little teleport in there. So if I now, and maybe one illustration is enough to give you a sense that maybe something like that is going on. So now if I show you that same clip here, the majority, maybe if not all of you, would now say like, yes, it prevented ball B from going through the gate. Because basically what I did is I changed your belief about what would have happened in the relevant counterfactual situation. Right? In the first situation, at least some of you, I think, probably thought like, oh, it would have just ended up somewhere there in the top left corner, right? But now that I've shown you this other instance, which changes your belief about the world works, accordingly your counterfactual would be different and would look more like something like this now, right? That yes, it would have gone in sort of through the portal in this case. So the fact that I can show you the exact same clip twice, right, and change your judgment about whether or not causation happens is, I think, quite strong evidence that these actualist accounts are not going to work. I don't have to use the teleport. I can also use this kind of block here and move it in and out of the way. Right? So here on the left-hand side, people don't say that A prevented B from going through the gate, whereas on the right-hand side, they do, right? Because there would have been a block that would have blocked it like a little bit later, on the right side not. And similarly for causation here. So on the left side, if I have a block that would have been in the way, people say, yes, A caused B to go through, but if I move the block out of the way, they don't. That's the question?
Does the actualist account have some stochastic element or some way that it also can generate a range of possible answers?
Yeah, it could. So that specific model that I've referred to, doesn't have that implemented. Like in principle, it can. In principle, it can even simulate counterfactuals. Like it does say that in the paper. You could imagine how people could use their kind of understanding of how forces work to simulate a counterfactual. It just makes the claim that that is a sort of, added, like something that you can do, but not a necessary requirement in a certain way to arrive at the causal judgment, right? So it could probably produce uncertainty, but not, this kind of, that it's particularly the uncertainty about the relevant counterfactual that determines your causal judgment. That's just not part of that kind of account, because they try to do away with counterfactuals. Okay, so this maybe is stronger evidence, right, for needing counterfactuals to explain people's judgments, but then we can still also ask the question is like, are people actually, doing that? So tracing kind of intelligence, I guess, which is, fitting for this workshop. And the way in which we traced it is by doing eye tracking, right? So we put participants in front of these videos, the simple ones, no teleport or blocks involved, and just looked at what it is that they're looking at when we're asking them different questions about those clips. And in one condition, we just asked them a question, and they knew what question they were going to be asked at the beginning about the outcome of the clip. So here's a participant that knew that they were going to be asked at the end of the clip whether ball B completely missed the gate. And the clip is playing at half speed, and the blue dot, right, is the gaze position, and as it's sort of changing over time. Right? So the participant is mostly looking at ball B. Now they're trying to anticipate where ball B ends up hitting the wall, looking some more at ball B, because that's all they need to do, right, in order to answer this question here in this case. But now if you look at a participant who saw the same video clip but was asked a different question about the clip, so this participant was asked whether ball A prevented ball B from going through the gate, and you'll see that the eye movements look very different. And I, the first time I ran this, had a big smile, on my face, because I could see it live, from the eye tracker, that it was happening that way, and made me quite happy. because it wasn't entirely sure to me. And when I talked to some people doing eye tracking at the beginning, they also say, hey, this is never going to work. Because when stuff moves, people want to look at moving stuff. They're not going to look nowhere when other stuff moves, right? But that's exactly what we're seeing in this case, right? They're looking at nowhere, like into this, where nothing is happening, but where they're anticipating, right, the counterfactual that would have happened if the other ball hadn't been there, right? And so the gaze pattern looks very different in these two conditions. This was just one clip, anecdotal, right? But what we did here is we just looked at all the saccades that participants are producing. So these are fast eye movements from one place to another, and where they end up. And we just looked at the time between when the balls entered the scene and collided with each other. And then looked at, okay, how many of those saccades end up on the path that ball B would have taken if ball A hadn't been present in the scene, right? And then we're seeing many more of those points for this causal condition, where in this video we asked them whether it prevented the ball from going through the gate, than we see in this other condition in here, right? Showing that participants are spontaneously engaging in this kind of counterfactual simulation when asked to make causal judgments specifically. Okay, so causal judgments, according to this model, are quite well explained by taking into account what observers' beliefs are about what would have happened in the relevant counterfactual situation, so how likely it was that the cause made a difference to whether or not the outcome happened, that these counterfactual contrasts are necessary for understanding how it is that people make causal judgments, and that people spontaneously engage in making these kinds of counterfactual simulations when asked to make causal judgments. We've used this model. Oh yeah, let's take a question first.
Yeah, just, I mean, maybe you're going to answer it. Can I ask you? I'm kind of wondering if you've looked at how early people can predict a causal effect in the future. For example, your first experiment, you know, maybe they don't actually have to see the whole collision, and they can tell within like 100, 200 milliseconds that there's going to be effect of A and B and so on.
Yeah, that's an interesting, there's two ways I think thinking about that question. One of which is sort of a question about, you know, will it cause it? Which is in some sense, and that actually we'll get back to that a little bit later, decision making, is you're anticipating the truth of some counterfactual, right? Because if causing means that the counterfactual is true, you're asking about that in the future, right? So will it be, if I stop the clip early, right, and ask you, is it going to be the case that A will cause B to go through the gate, right? I haven't done that. Presumably people, you know, can do it, but now they not only have to, right, simulate what the counterfactual would look like, but also predict like the future, which is a little bit more difficult in this case because you have to predict the outcome of a collision, right? In this case, when you're simulating the counterfactual, it's easier because all you have to do is sort of extrapolating some ball without anything else being present in the scene, at least in these simple settings, right? So I have not done that, haven't run this kind of experiment, but it could be interesting to see, you know, if people can do it, and also now they need to look at more stuff, right? They need to look at how is the collision going to play out, but also would the ball miss otherwise, right? And yeah, the other thing that we are seeing, and maybe you saw that in the video clip a little bit, so there are multiple instances, right, in which the participant tried to simulate at least the counterfactual in this case, sort of similar to how our model samples multiple cases. I think the setup is special also in some way in that, in this instance, participants know at the beginning that they're going to be asked to answer this question, right? Many times, I think, in our everyday life, we're not in that position. Some outcome happens, and then later I want to think about, oh, did this happen because of that? Right? And then, you know, it might not be the case that it's going to be supported by eye movements anymore, and that's why I was skeptical at the beginning also whether this would actually work out. But now the counterfactual is just playing out in our mind, right? What the eye movements I think here are happening is getting some additional precision that they would otherwise not have if I just surprised them afterwards with a question, hey, did it actually cause it? Right? So they're using it as a prop to getting a more accurate belief about what the counterfactual would have been. Cool. Just a couple of ways in which we've expanded on that model. So I showed you these quite simple cases, right, with only 2 billiard balls. We went all the way to 3 billiard balls. Sort of more complicated ways in which balls are interacting with each other. This is a case that philosophers love called double prevention, right, where kind of B prevents A that would have prevented E from going through the gate, right? And you can probably see that happening. We also looked at situations of causation by omission where nothing happens, right? And you might still wonder, oh, did B go into the gate because A didn't hit it? Now simulating what would have happened if that event had taken place. And even in situations where really nothing is happening at all, sort of what we call maybe sustaining causation here, you might ask a question about how responsible the black block is for, you know, the stability of this structure or the other one staying on the table. And you could imagine in this case what would happen, right, if this black block was removed. So a similar idea that you're using your intuitive physical model here to simulate this relevant counterfactual in this case, and where you can think of supporting as still a causal term, basically preventing something from falling. More generally, one thing that my lab is working towards is a computational framework for understanding responsibility. So this causal stuff that I've been talking to you up to now is one important part of that, right? We need to be able to understand how somebody's actions causally relate to the outcomes that came about in order to determine how responsible they may be. But once we start thinking about people and not just billiard balls, there are other parts that matter too, some of which have come up in Max's talk. So one important aspect when we're assigning responsibility is also thinking about what the action tells us about the kind of person that they are. Are they altruistic, selfish, or a Bayesian reciprocator, would just be one example, but more generally what their intentions and beliefs and desires are. And for that, we need some intuitive theory of how people work. And I want to share a little bit of that work that we've been doing. So this is now about how people judge, to some extent, whether somebody caused something to happen, but in this case specifically, whether they caused somebody else to be, hindered or helped in their outcome. And this is work by my PhD student Sarah Wu and Shruti Srita, who is a research assistant in the lab. And so helping and hindering has a long tradition in cognitive science. So this is some work from 2009 by Thomas Ullmann, Josh Tenenbaum also involved, and Chris Baker and others. And so they also had these little grid worlds examples, and they, in the task, what people had to do is try to infer what some agent's intention was, so whether their intention was to help or hinder another. And they incorporated what it means to intend to help or hinder, right? It's by basically, if you're intending to help, then you're placing a positive utility on the other agent's utility. And if you're intending to hinder, you're placing a negative utility on the other person's utility. And then they could do these kind of Bayesian theory of mind kind of models, right? By saying, oh, if your intention was to hinder, what action should what action should you produce to then do Bayesian inference on that and infer your intention from the action that they've observed you taking. Now, one important aspect, though, or point is, I think, that intending to help or hinder versus actually helping or hindering is not quite the same, right? And I don't have children yet, but I still like to use this example here of a child sort of helping with the groceries. Maybe Nate would be in that position. Well, we saw Nate actually being helpful, I guess, earlier in the Warneken example, Max's son. But here's a child, that's maybe trying to help, but not actually being helpful, right? They're making things kind of less efficient. It takes longer. Hopefully, eventually, they'll grow up to be a very kind of actually helpful helper who doesn't just have helping intentions, but actually helps. But there's at least a period of time, where you could see these two things coming apart, right? And so to judge whether somebody actually helped or hindered, I would argue counterfactuals are required, because it's essentially a comparison between, again, what happened because of them. Would it have been easier or harder if they had not acted in that case? So we also studied this in a relatively simple grid game. And so we have these two agents here, the red one who wants to get to the star, and then the blue one who we don't know at the beginning whether they're going to want to help or hinder red from achieving that goal. We also have these static walls here, and then these blocks, but only blue is strong enough to move those blocks, right? They can pull and push them out of the way. Red, can't do anything about the blocks. So here's a Hollywood clip of what's happening in this one, with a Hollywood ending, so happy ending in this case. So we would show participants clips like that, and then ask them different questions, again, different groups of participants, different questions about the clip. So one group here was, for example, asked how responsible blue was for red's success, like in this instance. So red also only has a limited time. You maybe saw the timer up there to reach the goal. Another group was asked a counterfactual question, so whether they believed that red would still have succeeded in this case, even if blue hadn't been there or hadn't helped. And then another group was asked to infer the intention that blue had in this instance, whether blue was trying to help or hinder in this case. And now the idea how we're modeling this, at least the causal aspect of it, is that it's in important ways quite similar to the other setting that I showed to you earlier, the physical setting. I mean, they still look like balls that have eyes on them now, but there's an important difference, right, in how we're now simulating what relevant counterfactuals would have looked like. Because now we have a generative model that involves agents planning, right? Rather than the physics engine that sort of dictates how the objects would move over time. It's now agents who are making plans and who are going to execute on those plans, and those are the relevant counterfactuals. And I can also envision now different kinds of counterfactual operators again on a world like that. But one at least is again to imagine what would have happened if the agent hadn't been there. You could also imagine if they had a different intention, or if they had been reasonable, like the reasonable person test in the law. There's many different kinds of counterfactuals you could imagine. But for now, we'll stick with the simple one. What would have happened if that agent hadn't been there? So the idea is, right, in the setting, we now just have some generative planner of agents going about their goals that are in line with their utilities. And we can use that planner for causal attribution through the process of counterfactual simulation, and also to make inferences about what the agent's intentions were in this case. In this case, we're interested in whether they're trying to help or hinder. And what we think is happening is that both of these aspects, like both what causal role you played and also what the action reveals about the kind of person you are, will be influencing the degree to which people will hold the agent responsible. So to make the analogy, at least on the causal attribution part, even more clear, right, is saying this was the setting in our billiard balls world, right? And then in our now kind of agent grid world, right, the idea is, again, you're imagining the blue agent hadn't been there, but now when you're simulating the counterfactual, you're using a simple planner in this case for the red agent. Like, how would they have walked if the other agent hadn't been there in the scene? And now for the person inference stuff, I don't have to say all that much because Max covered a lot of it already. In this instance here, we just assume that red has a simple physical goal, like they just want to get to the star. And then blue has this kind of social goal. They want to either help or hinder. And we also assume that blue can have a presentational goal. So they want the other person to think that they're helping or hindering in this case. So kind of signaling their intention. And we're then setting it up in this K-level recursive reasoning kind of framework, where it's starting with a simple red agent, and then adding like a level 1 blue agent that now, depending on what their goal is, whether they want to help or hinder, are going to plan to make that happen, assuming that the other one just wants to get to the goal. Right? And then we can go up that hierarchy. We can add a level 2 red one that anticipates, that tries to figure out what intention it is that the blue agent has, and then act according to that. And the highest level that we reach here in the setup is a level 3 blue one, who now also is aware that the red one is trying to infer what their intentions are. And they could now, for example, produce something like deceptive behavior. And to give you just a couple of examples of the kind of situations that we have in that paradigm, this one you've seen already. Here's another one. So very sad. And here's one more. I kind of played, maybe blue looks helpful, but it didn't end up actually really making any difference. So we had, again, many situations like this. And what we first wanted to see at is it going to be similar, like in the physical setting, right? That all we need to explain the extent to which people are holding the agents here responsible in this case is the extent to which participants think that the counterfactual, without the blue agent would have been different from what actually happened. And what we see here is that we don't get like as nice a relationship between counterfactual judgments and responsibility judgments as we did in the causal setting earlier, right, where these things were almost perfectly on a diagonal here. And we think that's because people don't just care about the causal role that the agent played, but also about what the action told me about the kind of agent that they are, basically whether they are the helping or hindering kind. So if you have a model that incorporates both of those, basically what causal role you played, and do I think you are a nice guy or not a nice guy, then that model captures people's responsibility judgments quite well. Yeah?
So do what they want to do and what they want to show match. Do you have an agent which wants to show they are helpful but actually wants to prevent?
Yeah, I'll show you one in a moment. Yeah, the other one is, so this one is a little bit more easy to imagine, right? So somebody who actually doesn't want you to succeed, but wants to look nice, right? You could also imagine the person who wants you to succeed but wants to look not nice, right? That's a little bit more difficult to imagine in a one-on-one setting. You could imagine it in a team setting, right? If I'm, playing for my basketball team, but actually all my friends are on the other team, right? And I still, want to look like I'm preventing, but in fact, I actually want the other team to succeed. So you could imagine a setting like this. In a one-on-one setting, it's maybe a little bit less common, but yes, at least that one agent we have. And I'll show you an instance of that in a moment. Just to give you some intuition about both of these things mattering, right? Here's just a pair of clips where the only thing that's different between the two clips is that part here, right? So there's a little thing missing, right, that now makes it such that in that clip on the right-hand side, blue could have gotten to the goal even if, sorry, red could have gotten to the star even if blue hadn't done anything in that case, right? And so what we're seeing here is that for the intention, where kind of up means good and low means bad, and the bars are people and the little circles on top are our model predictions. Like in both instances, people are pretty certain that blue wanted to help here. But then when we think about the counterfactual, the causal role, right, on the left-hand side, people think, yeah, no, red would not have made it without blue. And on the right-hand, they think, yeah, red would have made it even without blue. And then that translates into the degree to which they hold them responsible. That on the left side, they think, yeah, blue was really responsible, whereas on the right-hand side, not so much. And this is just one example to illustrate that this intention component also really matters. Right? We saw that clip where blue just puts this other block in front of a block that was already there. Right? And participants don't think here, right, that red would have succeeded without blue. So the counterfactual bar is really low in this case. They're also pretty certain that blue wanted to hinder in this case, and then still end up giving blue quite a bit of responsibility for the negative outcome in this clip. Okay, coming back to the earlier clip, so here's, once we have these, or this earlier question actually, once we have this sort of hierarchy of agents, right, we can also find things like deceptive behavior. So here's another kind of somewhat dramatic clip. So, and we also asked participants for free-form kind of descriptions of what they think happened in the clip, right? And here somebody said, well, blue tricked red into thinking she was going to move the box to help her, but once red was stuck on the side of the wall, blue left the box where it was, right? So in this instance, it might also be like they still wanted to look. It's also compatible with an agent that still also wanted to look hindering, but at least they exploited the fact in this case here, right, that they thought, like, okay, red is going to think that I'm going to help you, and then not do that, right? And maybe still have some plausible deniability at the end of saying, no, I didn't do anything in this instance. But here they hindered basically not by changing anything physically in the world, but by changing the belief that the red agent had, namely that they would help, and then in fact they didn't. Because red could have actually succeeded by going all the way around in this instance. Okay. So here, we applied now this counterfactual simulation model to thinking about how people assign responsibility to other agents, specifically in this instance, judging responsibility for helping and hindering. And I made that point that that requires counterfactual thinking, because we still need to compare what would have happened without the agent. And I've shown that the responsibility judgments are sensitive not just to the causal role that the agent played, but also to the mental states that we have inferred about the agent, so whether they were helping or hindering. Most of the stuff up until now, and as also sort of what the abstract was focused on, is kind of summarized in a review paper that I just got an email that the prints will be available in a bit, although I don't think I will get the prints. But it's in Trends in Cognitive Sciences called Counterfactual Simulation and Causal Cognition, so I encourage you to take a look at that if you like. But let me summarize sort of overall this first part, the role that counterfactuals play in explanation, so how we explain why something happened. I think it shows that people do so by relying on their mental model of the situation. This can be a physical mental model, like in the billiard balls domain, or a psychological mental model of agents interacting with each other in these sort of grid world scenarios. How there are mental models that support reasoning about the consequences of counterfactual interventions. In this case, they were relatively simple interventions, like removing an object or removing an agent from the scene, and then simulating how that would have played out. And that epistemic uncertainty, so sort of not knowing quite exactly what would have happened in the counterfactual world, are at least one important component that affects the degree to which people assign causation. Okay, that's the smooth part. Now we'll come to the bumpy part, unless there are any questions. I don't know whether that was a half race.
Yeah, I have a question about the role of sort of counterfactuals in responsibility assignment. So in the example you showed us, I mean, one way to view the clip is that the blue sort of pointlessly moving the block in front of the second block provides evidence that they were trying to hinder, and then that leads to this sort of counterfactual thing that's like, well, if the blue agent had been nice, it could have moved the thing but chose not to. But like the primary role of the movement is actually to provide evidence of their type, as opposed to what happens in the scenario where you just see the blue guy like wander around.
Mm-hmm.
You know, or somehow it's not providing evidence about its type one way or another, but nonetheless, like in theory, it could have moved the thing if it was a helpful agent as opposed to a different agent or a kind of hindering agent.
Yeah, that's a good question. And it depends, like, again, you know, currently how the framework that I've illustrated now would be handling it is sort of, certainly it didn't play any causal role in this instance, at least when the counterfactual operation is what did it if it hadn't been there, right? Because wouldn't have made no difference. It might still be an instance that you will infer that they, you know, I'm not sure whether you would be inclined even here to then infer that they have a hindering or helping intention when they sort of omitted an action. I think in our framework it will. So we have one instance where basically it just sits by the door, right? And there's like a block that it could have pushed into the way and it chose not to, and that it will infer from that, okay, it's definitely not hindering, so it will be pushed towards helping. There's another question, though, I think that's embedded in yours as well, and I think this kind of thinking that what the relevant counterfactual intervention here is just the agent not being there works okay-ish, but there's also certainly others, again, that you can think of, right? For example, what if their intention had been different? Or again, what if they had been reasonable, right? Maybe in general, we're inclined to think that people should be nice and helpful, and that's the relevant counterfactual that comes to mind. And so, yeah, there's other ways in which we can explore that too. We also have one instance, I briefly mentioned that, of we can get scenarios basically sort of victim blaming in our setup, because if two agents, imagine they act repeatedly with each other, right? And so the first instance, imagine that example that I showed you later, where you know, blue looked like as if they were going to move the box and they didn't do it, right? Imagine I showed that to you twice. So the same thing happens in the second interaction again, right? Now your inclination might be like, well, now it's partly red that's to blame, you know, for this negative outcome, because they failed to correctly update their beliefs about the blue agent, and that's part of their responsibility in this case. They should have updated their belief and acted accordingly, and so there's one experiment in which we show that participants are sharing these kind of intuitions there too. Oh, more questions? Yeah?
So I was just wondering, how is causal responsibility judgment affected in scenarios where the agent had best intentions to help but failed because of poor implementation, so some initial implementation gap, where, but then that's one scenario, and then another scenario where that agent tried to help and again failed, but also prevented some other agent helping. But again, not intentionally, they just couldn't implement their strategy that would have led to the agent benefiting.
Yeah.
So how does it?
Yeah, so this model, again, so far really just assumes a weighting of these two different sources, right? The agent who, you know, tried to help but failed at doing so will still not be, you know, getting a lot of responsibility for the negative outcome, because the observer appreciated the intention that they had in bringing about the positive outcome, but nonetheless, right, there's still the belief that, like, okay, if you actually had, you know, executed on your plan, you could have created this into a positive result. So I am giving you some responsibility for the causal role that you played. Right? It's really this sort of mix, again, of your causal role and what your action tells me about the intention that you have. Did you have any questions, though?
Yeah, it seems like there's a subsequent part about effortfulness. Right, I mean, I maybe call this the Midwest effect. Where, like, you know, you try, be nice, and you say, well, sorry, I can't really help you there, or like, pull in the wool. I don't know.
Yeah.
So, I mean, that might be something where effort is kind of an intervention. I also wonder, on top of sort of what was...
Just on that one, effort is actually in the model. So we do compute, right, like the effort that it takes for the agent to take certain steps, and also assume that moving an object takes more effort than not doing so. So it is, so for example, like that agent that kind of walks there and just moves the box out of the way, like it still gets this like, oh yeah, I see that you wanted to try and help, right? Because you produced some effortful kind of behavior here that it could imagine could have been helpful, but given how the red agent actually was, it made no difference.
Sure, I suppose, though, you could see, like, the box itself maybe just, you know, someone had the misconception of this box is really heavy, and I thought I misattributed my idea of, oh, this box I can actually move. I have a slight second question. In the law, negligence is, of course, a sort of standard bearer when it comes to things that one ought to do. Kind of actual thoughts, like Cushman has done some work on this as well. And I only wonder if that is also playing a role here where, right, it's if someone were to walk around, right, they think that they ought to do this, given that this is what a good person would do. Especially if someone's being hindered and assuming only hindrance. Have you done that where you're just looking at hindrance, not helping, and you just do various models of hindrance and sort of walking around those?
Yeah. No. So in those experiments, if I remember correctly, we've always done both together, like helping and hindering, but they're supposed to be different agents, like except for that one where I have them play repeatedly. And yeah, to your intuition again, I think there is a lot of truth to this idea of us at least sometimes simulating what the reasonable person would have done, and they, at least in general, tend to be probably, ones with positive intentions, at least. But creating the kind of situations where those would come apart, right, where we basically would make a different judgment if I simulate a reasonable person versus one where I'm kind of assessing their causal role more simply by imagining them not being there and also inferring what their intentions are, I haven't quite gotten there yet. One more question.
So how does one think about what it is that agents are doing with this baseline expectation of what a reasonable person is, or right? Is it themselves, right? Are they baselining against their own kind of action? Is it against some idealized, super rational agent? I mean, the fact that, for example, if I believed that there was some or is there an active learning process to discover the ability or disability of the agents involved? Like, I wouldn't assume that someone should have learned this if I thought they were a child or somehow otherwise distracted or unable to do this. So what is in some sense is the learning task underlying this assessment? Is it against some baseline? Is there a discovery of capacity and then against this kind of expectation, like a double expectation of what it is that they could do and then what they should have done relative to that? I mean, there's a whole bunch of moving pieces that are hidden from this exposition here.
No, I don't think they are here because I'm not actually doing that. I think all these questions would arise, right? In fact, if I was thinking that the counterfactual that people are running is what the reasonable person would have done, right? But that's not how I implemented it, right? The way that I implemented is that they're simulating what would have happened if the agent had not been there. Right? So that's a much simpler counterfactual. And that the other part is just really inferring the intentions of the agents. Are they helping or are they hindering? And then that they're weighing those two aspects to arrive at their responsibility.
But helping and hindering is relative to an expectation of ability. And if I don't think, I mean, if I think that they're, like, for example, is the person being sneaky and not, pulling this thing away when they thought they were pulling it away, that kind of assumes that I assume that they're playing 2 steps ahead in the game.
Yeah.
So I'm just saying that that does hide that. It doesn't, by saying that I believe they're intentionally doing this, itself has a baseline inside there. So how does one think? Do you either discover?
It's just that the way in which we capture sort of helping and hindering here, right, is by comparing it to the baseline of the agent not being present in the scene. And then it becomes relatively simple. I agree with you that in many instances, the baseline might be something like, what could I have expected somebody to do? And then a lot of questions arise about what the correct reasonable person in the situation is, right? Like, how much should I take their capacities into account, right? When it's a doctor, well, the reasonable person is probably also somebody who has a lot of knowledge about medicine and so on. And there's a lot of articles, right, also in the legal domain that try to characterize, okay, how do we make good decisions about what the reasonable person in specific situations should look like? But I'm dodging many of these problems because I'm taking my counterfactual operator to be like, what if they hadn't been there? And then that's my baseline.
Is it like they're seeing a whole bunch of these videos in a row or something? Is that the kind of basic?
They're seeing many in a row, but each of them is sort of like a single instance because they're not repeated interactions between the agents.
How do they know things like that the blue agent has that kind of ability to pull things and the red agent doesn't?
They're told about it. So they just know that the blue agents in general can move the boxes out of the way and the red ones can't. So they don't have to make inferences here about their capabilities, for example. But that, again, in instances could be interesting. Where they say, oh, you couldn't actually have helped because you weren't able to do so. Right? And you might only learn that later and then not give them responsibility. Okay, let me share a little bit just about this second project. On decision making, and this is something that a student that I've been working with for a while, Ricky Ma, has been working on, and also my collaborator Thomas Eichhardt. And so The motivation for this project, right, is that I was fairly certain, hopefully you are somewhat too now, that counterfactuals play this important role when we're explaining things, right? But I was also thinking like, I have this hammer now, are there more situations that I can apply it to? And so I've been thinking about decision-making and the role that counterfactual thinking plays in decision-making. And you might think like, well, maybe not much, right? Because counterfactuals, by definitions, are about thinking about how things could have gone differently in the past, right? And whereas I make decisions, it's the hypotheticals that matter. What should I do? Should I take this action or that action? And sort of in normal kind of, expected utility theory, you don't really find kind of counterfactuals in there, right? It's just the probability of different outcomes, and I'm choosing by maximizing the expected utility of these different outcomes. But at least in some instances, the outcomes that I care about, I would argue, are actually counterfactual outcomes. So let me just illustrate this with this example. So we have Blue University and Green University here. And Blue University only cares about, when making decisions about who to admit, about the probability that the person is going to succeed at that university, right? So they might take, these two people here in this case. But now Green University has a different criterion. It cares about to what extent students would benefit or be harmed by coming to their university, right? So what it tries to assess is like how much higher their chances are of success when they come to their university compared to what some other university could have been for them, right? And this university might make a different decision in this case about who they're going to accept, right? So Blue University doesn't need counterfactuals, right? Because all it cares about is just assessing the probability of success. But Green University arguably does need counterfactuals. Like they care about maximizing sort of benefit or minimizing harm to students because of their admissions decisions, and that's a counterfactual criterion. Right. So for some things, again, some notions like regret, right, it's very clear to us that this is a counterfactual notion, and there's work that we make decisions partly by anticipating the regret that we would feel, like if this was going to happen or that was going to happen, right? But basically what I'm arguing, there's a whole bunch of other notions that are basically counterfactual too, and that maybe at least wasn't so obvious from the beginning that they are, right? I've already argued that helping and hindering is a counterfactual notion, benefiting, harming, saving, killing, these kinds of things. So when you care now to make decisions about that's the thing that I want to optimize, what you're doing is you're basically anticipating the truth of different counterfactuals. So it turns out that this kind of counterfactual thinking is also critical for when it is that we want to make good decisions based on having different sources of data. So in this case, kind of some experimental data and observational data. And at least in general, we as society, I guess, find ourselves quite often in domains like that, right? So you could think in the medical domain, where we might have some randomized control trial data, but then also a lot of observational data, where people chose themselves whether or not to take the treatment. So now we have these two different sources, and based on that, we want to make a good decision about, should we administer treatment, for example, to a new patient that we have? And this could also apply to things like online advertising, right, where these companies run lots of A/B tests, but then also a lot of it is just observational. So we choose to click on things or not. And again, based on that, they're trying to make a decision, should I place this ad? Should I send you this email? Yes or no? So in our experiment, we made it a little bit easier for people. So imagine, again, now that you're working at Orion Theater, and they've run some experiments, because they're up to date with the trends. And they're interested in flyers, basically, where the flyers work in kind of increasing the likelihood that somebody's going to go and see a movie, right? And so they ran one experiment where somebody was standing outside and randomly gave some people a flyer and some people didn't, right? And then recorded whether they ended up going to see the movie. And then they also ran an observational study where the flyers were just available outside and people themselves could choose whether or not to take a flyer. And again, they recorded whether they ended up going to the cinema afterwards or not, right? So now we may have data that looks something like this, right? Where we have on the left side our experiment. At the top, you see those were the people who were given the flyer. At the bottom, the people who weren't given the flyer. And you can see how many out of 10 here ended up buying a ticket to go and see the movie. And so the left side is the experimental study, right? And the right side is the observational study, where again, in this case, 10 people ended up choosing the flyer, 10 people ended up not choosing the flyer, and then some proportion of them ended up going to see the movie, and some didn't. Right? Okay, and so now you could already imagine, like, okay, if I have this kind of data, how would I make some decision about whether or not I should hand out a flyer, at the cinema? And here's kind of one part where the counterfactuals come in. We can think that there's basically 4 different types of people that exist, in this world here. And we have a simple binary world, binary cause, like you get the flyer or you don't get the flyer. Binary outcome, you go to the cinema, you don't get to the cinema. So there is a complier, Mary here in this case. So that's a person who goes to the cinema when she gets the flyer, but wouldn't go otherwise. Right? There's an always taker, Jerry. who goes, no matter what. The flyer makes no difference to him. A never taker, Larry, also the flyer makes no difference to him, but he doesn't go no matter what. And then we have the defier, Carrie, who would go to the cinema if she didn't get the flyer, but if she gets the flyer, she's put off, by the movie in this case. And now what I'm going to do is I'm just going to put some values on these different people, like for you. I'm going to say, okay, if we get a complier, yeah, that's worth $10. If we have a defier, we lose $20. And then for the flyer, we have to pay 50 cents, kind of. So then we have these values here. We have $9.50 for a complier. Here we're just losing the value of the flyer in these instances. And then the defier is really bad, right? Because we have to pay for the flyer, and also they're not going to come and see the movie, so we've lost a customer in this case. Okay, hopefully you've taken that in. Now is another round of experiment here, where you now get some data, and I'm going to ask you, what do you want to do in this environment here, based on the data that you have? So you have some experimental data on the left-hand side, some observational data on the right-hand side. I told you how much these different people are worth to us, right? What you want to do. Do you want to hand out flyers at the cinema, yes or no? And I'm going to press the button, and the thing's going to move from the left to the right, and you just clap when it's at the location that you would have clicked, right? So let's do that. Some very hesitant claps. A little more on the right-hand side. Okay, here's another one. Different cinema. We again ran some experiment and some observational study. This is how the data came out. What would you do in this cinema? Okay, very hesitant claps. And I don't know whether there was a big difference between the claps. Maybe there was a little bit, well, I actually don't even know whether there was a big difference between the claps. Maybe you're sort of like, oh, the observational stuff didn't matter, right? Because the experimental data was the same in both instances, and maybe you're just, that's all I need. Experiments are best, right? That's what we learn in stats. So I can just ignore the other part and make my decision based on that. So in principle, right, the goal is the following, right? You have that data, you want to infer from that what the different types of people are. Once you know that, right, the probability of the different types, then you can make a good decision, right, by now optimizing this expected benefit by taking into account the probability of the different kinds of people, right? And the different types of people, that's the important part, those are sort of counterfactual people, right? Because they're basically the person that complies, that only goes because they get the flyer, that they wouldn't have gone otherwise, right? And the defier is the person that would have been harmed, by your treatment, the person that would have gone have they not gotten it. So the thing that I'm optimizing over is I'm anticipating the truth of different sort of counterfactuals, which are these different people types. Okay, so how can we use this experimental and observational data to infer what the different types of people are? And let's start just with some experimental data in this instance here. And I'm just trying to get the intuition maybe here across. And let's say it looks like this in this instance. And I'm going to just say, like, I'm just going to compare two different possible models of how this data could have come about. One of which is that half of them are compliers and half of them are defiers. What that means is that half of them went, because of the flyer, and half of them didn't go because they got the flyer, right? And the same is true for the other condition where if they didn't get the flyer, half of them would have gone with it, and half of them didn't go because they didn't get it. Right? That's one possibility, one possible model of the data. Another possible model of the data is this one. It just makes no difference to anyone. Right? So half of them are always takers, they would go no matter what, and half of them are never takers, they wouldn't go no matter what. And then we had the same proportion of these people in both of the groups. Right? So that would mean like the flyer makes no difference, whereas in the model one, the flyer makes a lot of difference, it makes a difference to everyone, right? But it just flips them depending on who they are. So that's with the experimental data, we can't tell the two apart, but now let's say that we have observational data on top of that, and it looks like this, so that all the people who chose the flyer themselves ended up going to see the movie, and the people who didn't choose the flyer, when they got to choose themselves, didn't go and see the movie, right? And so now we can see, does this help us, basically tease apart which of these two models it could be? So is the observational data useful? And here we could say, okay, maybe the compliers were all the ones that took the flyer and ended up going, but then we have a problem with these ones because these ones aren't defiers, right? If these ones are defiers, then they would have gone if they hadn't gotten the flyer in this case. Right? Because a defier, again, is someone who goes to the cinema if they don't have a flyer, but would not go if they did get a flyer. So this model is sort of ruled out by this observation down here. Whereas this one is consistent with it because it just so happens that all the always takers took the flyer and all the never takers didn't take the flyer. So based on this observational data, we were able to rule out model 1, and only model 2 is consistent with it in this case. And interestingly, if on the right-hand side, we just flip it around, right? So now I put all the people at the top are the ones that didn't end up going, and the ones at the bottom, it did end up going. That again rules out this first model. I have to go a little bit quickly here. But the second model is consistent with that. It just now means that all the always takers, for some reason, ended up not taking the flyer, and all the never takers, for some reason, ended up taking the flyer in the observational study. Right? So again, we were able to rule out one of the models based on the observational data. And then here's the example that would rule out model 2. So if on the right-hand side, nobody ended up going when they chose the ones themselves, that is consistent with this model here, and just assuming that, okay, for some reason, all the defiers ended up taking the flyers, and all the compliers ended up not taking the flyers when it was themselves. And it's not consistent with the model on the right-hand side, because where are the always takers here? Right? Nobody has a positive outcome in this setting, so it cannot be that half of the people in the population are always takers. And again, same reasoning, just flipped in the other example here. We don't have any never takers in this instance, so it can't be model 2. So what it shows is that the experimental data, together with the observational data, allows us to make inferences like about the population. And that in this instance here, that despite the observational data being quite different, it's the same model. The expected benefit is the same, and the same is true here at the bottom for these two situations. So this was just an extreme case, but where I've tried to illustrate to you that the observational data can be helpful to figure out what it is. And then people have developed, people here being Pearl and Balki, I don't know the person, how you can do this in general, right, for any possible kind of combination of observational and experimental data in this case. How you can infer the probability that somebody is a complier by taking these two different data sources into account. Here the experimental data in blue and the observational data in green. And I'll flick over a couple of slides quickly here. It just sort of illustrates that here, if you only have experimental data, you cannot infer the probability of the complier is as well. So in this case here, you still have some range of possibilities. Whereas if you have both sources of data in this instance, you can infer it with certainty in this case. So you know for sure that there's a probability of 0.5 that somebody's a complier in this setup. We can do the same things for defiers, right? Those are the ones that are harmed, by getting the flyer. And then we can also compute what the probability of the other different types are. Here by taking into account, for example, if you have experimental data and we have the positive outcome, there's only two ways in which this could have come about. Either because somebody was a complier, so they went because they got the flyer, or they would have gone anyhow. And the negative outcome, there's also only two ways in which this can come about. Either because they didn't go because they got the flyer, or they would have never gone. Right? So this allows us to determine the 4 different types. And then the game now basically becomes, right, I have this data, I can infer what the 4 different types are based on the data, and then I can compute what the expected benefit is. And this is for the other example that I showed to you. Okay, now in the last maybe 1 or 2 minutes, do people do that, right, was what we were interested in. So here's a normative model about how you should combine these 2 different sources of information. Are people capable of doing so? And we did this in kind of 4 different experiments that I'll go very briefly. Either we just asked them to make decisions and they didn't get any feedback, or they got feedback afterwards. We told them this was the right choice and you gained that much, or this was the wrong choice and you lost that much. We also asked another group to first tell us kind of what the data looks like, to just really make sure that they're paying attention to that. And finally, we asked participants to infer what the different types of people are, just like I showed you earlier. So how many of them are compliers and so on. So the no feedback condition, just make a decision. The feedback condition, afterwards you get feedback, was it right or wrong, and how much did you lose or win? In the data composition one, we asked them just to report basically the numbers kind of in here, so just making sure that they're paying attention to the data. And then in the people inference condition, we asked them, okay, what proportion of people were encouraged by the flyer, would have gone anyhow, basically the 4 different types. Right? And we were interested in whether that would affect the decisions that they make. So here's what we found. So the maximum is like, this is as well as you could have done, this is chance performance, and this is as poorly as you could have done. And we're finding that in this kind of no feedback conditions, these are now, each participant is just how much bonus they ended up getting at the end of the experiment. Doing better than chance, but certainly quite far away from, at least many of them, how well they could in principle do. right? This is when they get feedback. So there's 22 rounds in total. So it wasn't the case that participants were able to learn very well from the feedback that we provided in this case. They still struggled with it. And then in the conditions where we asked them to sort of pay attention to the data a little bit more, they were performing better, but still quite far from what the ceiling would be. I'll show you just one or two more slides and wrapping up. So what this shows you is that people have trouble doing the inference as predicted by the model. So these are the 4 different types of people: complier, always taker, never taker, defier. And this is the points, what they should say, and this is what people do say. So it's not something that comes intuitive to people. What they do though, is like the inferences that they make about the different types of people does affect the decisions that they make. So you can almost perfectly predict whether people are deciding to give the flyer or not based on the inferences that they themselves made. So I'll wrap up here. We did some modeling also trying to explain what the factors are that people are actually using when making the decisions. And it turned out that a relatively simple model that just linearly combines the different data sources explains it well. So this counterfactual logic in this instance doesn't come natural to people. So to sum this part up, so counterfactuals are critical for making optimal decisions when we have both experimental and observational data. People don't follow the predictions of what a normative model in this instance says they should do. Their decisions, however, are consistent with the inferences that they're making. So it's not that they're ignoring the data, they're using the data, it's just that they're not using it in the right kind of way. And that their actions are best explained by a model that just simply combines the different sources of information linearly. Okay, so with that, hopefully I've been able to kind of tease you a little bit about the role of counterfactuals in causal cognition and the role that they play both for explaining and also at least a little bit the role that they might play for how people make decisions. And thank you for your attention.